Hi everybody, I'm Nurullah Shirimikov and my academic advisor is Ruslan Isaev. My master's thesis title is Machine Learning Model to Construct Quantitative Measure. The main goals of this project, this diploma thesis is develop a model that can accurately recognize measurement concepts building the dataset that includes the list of measurement concepts used in measurement units incorporate machine learning techniques such as natural language processing and neural networks, and to improve the model's ability to recognize patterns and make accurate predictions. So, completed task: model training, data aggregation, data tokenization, lemmatization, clearing data from stop words, text data vectorization, and training for the best model. Uh, so we have used these techniques: data cleaning, vectorization, tokenization, loading data, machine learning, logistic regression, random forest, and other. So preparing data is, as you see in the table in the right side, it's like measure kilogram, and in the left side there's a sentence with a measure, and on the right side there's a sentence without measurement units. So we describe this measurement unit as a weight, and the unit of measurement is kilogram. So this is the sample of our coding. So next step is preparing data for training. So this we call it data tokenization. So in the first row you can see the Turkish sentence, and this and second row is measure, unit of measure, and the next row is tokenized text. So when you're later I will show you how the coding is working. So this is the sample of the coding, and next step is lemmatization. So after tokenized text, we lemmatizate this text, and the sentence will be percolate almak istemek. So it mentions about the words as a dictionary, which their states are in the dictionary. So this is the sample of the coding. And next step is clearing data from stop words. For example, et almak istemek. So it clears the unnecessary words without meaning, and it goes to the data clear XLS file. And next one is text data vectorization. So as you see, it converts to the numbers, and this is the coding sample of the vectorization. And second part is search for the best model. The pipeline model is optimization of research, optimization for model parameters. There's just a point of variance of parameters. So the researcher can set an arbitrary number of options for the value of this parameter in the model, and research your maximum. The researcher can set an arbitrary number of options for the value of this parameter model. In gram number, researcher can set arbitrary number of options to value this parameter in the model. Usually it's 1, 2, 3. Model technique works. There are supported machine classification years, inputs, random first gradient, and artificial resolution. So next chapter is training the best model. The MI pipeline model also implements the process of learning best combination of pipeline formats and the entire vector data to train model saved as model NLP file. Model is for real data. The stage trained model with the best pipeline from the model NLP issued the text analyze model. Each sentence can contain more than one measure of measurement, thus some of the proposals may not contain a measure of measurement. So this is the coding sample of the training based model. This is text analysis. So this is the sample of our stories in Turkish. And here is the text analyzed text that, for example, in the fifth row, you see that ilk ekmek 300 gramdı. So there is a tokenized text, lemmatized text, and the measurement unit is gram, so it's weight. And there's other. So conclusion: the next file processing pipeline developed and test and regulate automatically find and measure in the text and compares a point the corresponding measure. optimization automation with the measures and additional results based on list of keywords with the lowest grammar and accuracy in the source text. The pipeline with the optimization automation for the best parameters, and if you change initial learning text, you get another best model. It means that your version model much longer has proper adaptation for text, and this is good result step-by-step operational learning. So it's loading data tokenization, democratization, data cloning, and vectorization. Thank you. So I will share you now. So this is our data, and this is first the first coding is preparing data and text tokenized to text and text lemmatization, text clear, vectorization and pipeline and text analysis. So when we run the prepared data, it's now running, and the result uh, the result goes to this file, and when we renew it, goes to the text data result, and when we click it, so we see like kilogram, and there's a weight. So in this sentence there's a measurement units, and in this sentence there are no measurement units. So it's like that data collecting, and then we go back to the coding page, and there is a text tokenized text by, and when we run it, it's now running. So it's analyzing 5 files, and the result goes to the text, goes to the result. So here's the data token. So this is the tokenized text. So here are the text, here is the measure, it's the units, and this is the tokenized text. And then we go back to the coding, and then we run next coding, and it's now running. Uh, and it's, I think it goes to the next step. So we go, then we renew it again, and so it's like limit size text. So here you can see that there's one row and it's new row, so it's limit size text. So then we go to the next step. So structure. So again we go to the data lemmatization, and so and then there is a clear text and text clear vectorization. So when we run it, it takes a lot of time, especially my pipeline. There is a text analyze. So when we can run it's clear, text clarify. So it's running, it's analyzing 7 files, 5, 4, 3. It goes to the result. And when we click it, and then we share, them here, and when you renew it, so there is a clear, this is clear text. And then we go back to the coding, and there is a vectorization, and when we run it, it takes a little bit more time. So it's analyzing. So when we run that code, they go to the result file, and so text vectorization is here. So this is vectorized text. And then we again go to the coding. So this is my pipeline. So when we run it, it takes a little bit much more time. So that's why we just can see here the result. And it goes to my pipeline. Okay. Now we will run the last coding, and this is text analyze. So when we run it, it starts to analyze the text. There is a sample text in Turkish language, so it's analyzing it. And it goes to the result, and when we see the when we go inside the file, and there is a text analyze result, and so we can see here, for example, here is ilk ekmek 300 gramdı, so there is a unit gram and its weight. So the coding is working, and if you change this sample text with with a novel, so machine learning model will also analyze that text, and it's a good result. It's working. Thank you for your attention.